Hello everyone, in this video I'm going to solve this recursion problem, that is permutations, and the statement says this: given an array nums of distinct integers, return all the possible permutations. You can return the answer in any order. And this is the definition of permutation. A permutation is a rearrangement of all the elements of an array. Okay, so for this input, this is all the valid permutations. Okay, and we have a length of 6, and all the integers of nums are unique. Okay, so this is a really easy question. For this we are going to use, okay, we're going to use recursion, and we are going to use a for loop in the recursion call. Okay, because we need to try all the numbers. Okay, for each call we're going to iterate over all the numbers in the array. Okay, so when know that we reach the end, so when our index is equals to the num size, I'm going to call n. That means that we have a valid solution. Okay, when our index reach the end of the array, that means that we have a valid solution. Okay, and we are going to use an extra vector that is going to be used to see if we use a single number in the previous call. Okay, because the permutation we cannot repeat the numbers. Okay, so I think with these four steps we can solve this question. Okay, so I'm going to declare first, I'm going to declare n as the length of the nums. Okay, and I'm going to declare the use array. Okay, the use array is going to be of size n, and is going to be initially with false values. Okay, so we are going to return vector of vector int. So I'm going to declare my ans. Okay, this is my ans, and I'm going to generate a vector for each recursion call. Okay, in our tree is going to be build a sequence. Okay, so we are going to pass another vector that is going to be all solution. Okay, so for example our recursion is going to generate this vector, and this is going to be this solution, and for the next is going to generate this solution, and we're going to store it here. Okay, all the possible and valid combinations or permutations, we're going to store it in this vector. Okay, so I think this all. Let's declare the function. I'm going to declare the function as void because we are not going to return anything. So I'm going to pass the vector that is nums. Okay, the array. I'm going to also pass the vector use. Also I'm going to pass the vector ans. That is my ans. Let's reduce this. This is my ans. I'm going to pass also another vector that is the solution. I can avoid passing all these parameters, declaring as a global variable, but I'm just passing here. You can do it. You can declare these variables or these vectors as global, but I'm going to pass it here. Okay, but you can do it whatever option that you prefer. And I'm going to pass also an index. Okay, I'm going to also pass an index, and I think this all. So as I said, our base case is when n is equals to n, and n is equals to num size. Okay, so when we reach this index, I'm going to push back a new solution in my answer, and I'm going to return to break the future recursive calls. Okay, because I found the current solution. And here I'm going to, so I did already this. Let's erase. I'm building the recursion, the function. Okay, I declare the use vector, and I'm going to for loop. Okay, I'm going to iterate over I is equals to 0, and all the numbers, is the numbers of nums, and I is less than the num size. Okay, and here I'm going to ask something. If use it and nums ni or ni is used, that means, because I'm going to have all the values for the nums can be negative. Okay, so I'm going to use, if use and I is not used, then I'm going to add this number to my possible solution. Okay, so I'm going to push back this nums and I'm going to push it back. I'm going to mark this as true because this means that I can use it again until pop back this number. And here I'm going to call the recursion call. Okay, I'm going to pass nums, I'm going to pass use it, I'm going to pass ans, I'm going to pass sol, and I'm going to pass index. I'm going to increase the index. Okay, because for the next position that I want to the second, and for the next I want the third, and so on. Okay, the first call I have 0 here. I'm going to put the first element, and for the next recursion call I'm going to pass the second element to the next, the third element, and so on. Okay, so once I finish to process this, I'm going to pop back this element because I need to use another one, and I'm going to mark this as false. Okay, but I think this is, I'm thinking that this can be index. Okay, because for the first call I'm going to use this one, I'm going to use this one. No, I think this is okay. And I think this code is going to generate all the valid permutations. So let's call this function. Okay, now we are going to return nothing. Let me call the recursion or the function. I'm going to pass nums, I'm going to pass use it, I'm going to pass ans, I'm going to pass solution, and I'm going to pass index that is going to be 0. Okay, so after that I'm going to return my ans, because my ans is going to be store all the valid solutions. Okay, let's run the code, and we have accepted. We have accepted for these best test cases. Let's submit if this code can pass all the test cases that lead code give us. Okay. Yeah, as you can see, this is a very good solution. This is 0 milliseconds, and we have a very good time memory, a space complexity and time complexity. So this is a very good solution. And as you can see, we use recursion. We use the for loop to generate all the possible permutations, and we use the used array. Okay, so with these four tips, we can solve this question. Okay, and what is the time complexity for this question? Honestly, I don't know because this can be all the permutations. We're generating all the permutation. In this can be the time complexity, but let's call it big of all the valid permutations. Okay, and this is going to be time and a space complexity. Okay, if someone of you guys know the exactly time and space complexity, please tell me in the comments. But for me, I just have this time complexity because I don't know how to calculate correctly, but I think with this is fine. And this is all for this video, and see you in the next.